the assembly and disassembly using the Festo distribution and sorting stations. My name is Elsie Mugoni Makara.
I am Joy Wajira Mumbi.
And I'm Tamajo Mbura Kinyanjui.
Welcome. So our main objective of this project was to produce 3 types of widgets. In this case, our widgets are our pink block, our silver block, and our black block, according to the customer's order in a just-in-time process.
The main problem we're trying to solve is the need for customization of products, as has been a growing trend in the market. We've also tried to reduce overproduction in the industry, which is one of the main risks.
We first figured the layout of our system, and then we continued to add a few components that were not there. Then we continued to wiring and writing the code, and also integrated with the user interface for the customers.
For the layout, the first thing we did was to make a very rough sketch of how we wanted the whole station to look. For the first constraint, or what we were limited by, was space. Because we're using the Festo sorting and distribution station, the existing table space is slightly minimal, so we had to adjust the whole process to come up with a process where we'd use 4 conveyors, 2 which were already existing for both the sorting and distribution, 1 which we use for rejection, and a 4th one which we use for disassembly. So for the whole process, of how we came up with the process was that first a block would be rejected from the magazine. It would go to a detection point, which we call the part present, where we have 2 optic sensors and 1 inductive. So one of the optic sensors has the emitter and receiver on 2 different ends, and thus it could be able to detect all 3 blocks and use it specifically to detect or to identify a black block. So for the whole process, of how we came up with the process was that first a block would be rejected from the magazine. The photoelectric sensor has both the emitter and receiver on one end, and it uses reflection as a mode of detection, and we used it specifically to identify the pink block. For the silver block, we used the inductive sensor to identify it. After the blocks pass the part present, they can either go to the rejection point or the assembly point based on whether the part detected is what we had ordered for. At the assembly point, we send a signal to the robot arm, and it calls for the robot to come and perform the assembly motion. And after assembly is performed, the block is stored at the chute. If the block detected is not what we wanted, a deflector is used to deviate its path to the deflection, or rather it follows the rejection line, where it goes to the 4th conveyor and it is returned to the magazine.
Disassembly happens such that once a body is detected, the robot arm is called for disassembly, and once the lid is removed from the block, a conveyor 4 runs again, and it takes the block to another designated area where it is returned to the required magazine using a vacuum arm gripper.
And so I just want to show you how the interface that we made, the customer user interface. So this is our order page, and we will put an example of an email like the ones you have tried with here, and we will order the block silver. And if I press the button order, the stations should start. Assembly is now being done using the robot arm, which we integrated with our systems. The order is now complete. That was just the assembly process.
So right now our system is off. When we press the start button and we place an order, say we order a pink block, we'll observe that our system starts running. So a pink block is ejected and it goes to our detection point where it is determined whether it's pink, black or silver. It then goes to our assembly point where the robot arm picks a lead from our scheduled points, and as we can observe, the assembly process is taking place. After the lead is placed, the deflector, which is holding our block at the assembly point, goes off, and our block goes to the chute, which we are using as our storage point.
So in this process, we will be looking at how our system also deals with rejected blocks, since this is randomly chosen blocks and we don't know how they are arranged hypothetically in our magazine. So we will place another order. So I will use an example of an email, and I will put an order of black, and then I will order. When the system starts, silver is detected first, but that is not what the customer wanted, so it is rejected and is supposed to go back to our magazine, and black is then ejected and goes to the assembly point where the robot detects that it should pick a lead. And it's then assembled.
For our disassembly process, we use a HMI screen to enable it. So when you press the disassembly button, the conveyor process goes on, and it requires a block to be present so the disassembly process can actually go on. So when you place an assembled block and it goes to the detection point, the robot arm is called for disassembly. And it should go to the next detection point, which is our return point, or the point where the vacuum arm picks the block and returns it to the magazine.
So we also configure the HMI, and our HMI consists of our home screen, and it also consists of other screens which will show the processes, like the assembly process, the disassembly process. Now, for example, if you go to our processes, it will show you that our conveyor 2 has come on, and now if we go back to assembly now, it will call the robot arm. Now we can see that the process is going on. So this is just a visual aid to help us see the processes that are currently going on. So as we wait for the assembly to happen, we will see that widget assemble will come on. So right now assembly is still taking place, and once the assembly is done, our conveyor 2 comes back on and our widget is now assembled. What happens in terms of rejection? So in this one, our conveyor 2, deflector 1, conveyor 3 and conveyor 4 go on so that they can so that we can see the rejection line, and that automatically joins our disassembly line, which you can see that the part has returned to our magazine. And this is basically just the disassembly or the rejection taking place since it's conjoined with the disassembly process. So we will now explain the codes, and we have two PLCs. We have PLC 1, PLC 2. So PLC 1 belongs to the distribution station and PLC 2 belongs to the sorting station, and we also have a HMI. So we have different function blocks. We have a main program function block, which basically dictates the main functions, or the main, I would say, components. So we have a push, extend cylinder, we have our conveyors, we have our sensors also, like for our detection points. So this is just our main program. And then we also have for our modes, and we have automatic modes, manual mode, start mode, stop mode, and reset mode. And we have now a node red. Now this is what will dictate what comes from the node red, how it will affect the code that we have. So this is just in case of an order, and this is if a block is rejected and it wasn't the order that was placed by the customer. And these are just the different colors: our pink, our silver, and our black. And we also have our operating panel code. So as of now, none is on, but yes, none is on, but if you were to press like reset, it does turn on. So for our PLC2, we have divided the code into the assembly, disassembly, mode functions, operating panel, and rejection line, since all these components are connected to our PLC2. So in our assembly line, we have these steps, the conveyor 2. We also have the deflector 2. This is where the robot arm is also called. And this is now where the order is completed. And in our rejection line, when an order is placed but the block ejected is not the one, we have our deflector 1, which diverts our block to the conveyor 3, which comes on. We also have our conveyor 2, and we also have a signal from the previous PLC, which is this moved current step. And from the rejection line, we go to the disassembly line, since they are joined. So here is where we also have the conveyor 4, and we have the signal to start our disassembly. So we have conveyor 4. We also have calling the robot for disassembly, and it continues to when the block reaches the end of our conveyor 4, where it is now returned using our vacuum arm. Yes, that is all. And the mode functions and the operating panel are the same as the conveyor, the PLC 1. And when we come to the HMI, we have our different screens. We have our assembly screen, we have our disassembly screen, we have our home screen, we have our intermediary processes screen. This is where now we'll see the sorting. And we also have our rejection process. So these are just visual. to help us see what is happening, to help us see which actuator is on. And that is just a simple explanation of our code. In a bit about the Node-RED. So we use Node-RED to also create our user interface. So this is the HTTP in and this is the HTTP out. So this one just enable us to be able to create a web page that can be accessed. So we have created also a database locally that we can be able to store our customer data, and a template for styling our web pages. And we have also function blocks which manipulate the data from the databases to be able to match them up to the memories in our PLC code. And these are the memories that we are writing to in our tier code. And once everything is done, we also need to reset it. So this is what we have used to be able to read the value if assembly has been done and if the order has been completed, so as to reset and wait for another order. To observe how Node-RED plays a part in the PLC program, so we'll go to our user interface. And in our user interface, we will just pick a random order. In this case, we will order black. And once we press the order, we will come to our tier portal and we can see that black now has been set. So that is just how the customer user interface and our PLC systems are connected.
This has been it for our project. I hope you enjoyed it.
Thank you.
Thank you.